Hello guys, today we are going to create confetti in Houdini. In this tutorial, we will understand how we can control the orientation of confetti using some Vex and Bop. This is my reference video. I will give a link in the description so you guys can also check it out. Before moving further, make sure to hit the like and subscribe button, so that I can make this kind of more awesome tutorials for you. Let's dive into Houdini. Take a geo node. Take a sphere and convert it to the polygon. Move it slightly upward on y-axis. Reduce the uniform scale to 0.2. Increase the frequency to 4. Take a transform node. In the translate y-axis, write this simple expression. We are using sine function. Turn on the transform display flag. In the rotate y-axis, write $F multiply 5. Select sphere node. We need to move the sphere by 3 meters in x-axis. Now add a null node and named it as out. Again, take a geo node. Now take an object merge and bring out our null node. Now take a point velocity node and keep all parameters default. If you visualize our velocity, you will see that the velocities are straight. Take a null node and named it as out mesh. Add a camera and adjust the view as you like. Now take a subdivide node. Increase the depth parameter to 2. Take a UV texture node. In the texture type, select perspective from the camera. In the camera, select the camera that you created before. Change the attribute class from vertex to point. Now take an attribute from map node. In the texture map, select the rock basicolor texture that Houdini provide by default. Take a timeshift node. In the clamp, select clamp to both. In the start frame, break the expression and type the first frame of your timeline. Take attribute copy node, and copy color attribute from the second input. Again, add a normal node. Now take a trail node. As you can see, we have made copy of our original sphere. Now we are going to merge both the sphere using shrink wrap. Take an attribute transfer node and copy all the available attributes from second input to first input. Again, add a normal node. Take a point velocity node. As you can see, now the velocity has been twisted as per our geometry motion. Take a scatter node and scatter 40 points. In the global seed parameter, keep the value $FF. We need to calculate the p-scale attribute and orient attribute before we move further. To do this, we need to take the attribute wrangle node and write this vex code. Basically, this code is just calculating the p-scale and default orient attribute. And we are making another attribute which we will be going to use later onward. Now we are going to make a noise that we will use to delete the point which has a value less than 0.2. To make this, take an attribute VOP node and dive inside it. Take a mult constant and increase the multiplier to 4. Take a vector to vector 4 and connect it. This will going to give us 4D output. Take an anti-aliased noise. We are going to use two noises with different frequencies and offsets. So duplicate it and adjust the parameters. Add a fit range node to both the noise and adjust the source min and source max value. Then multiply both the value. Now take a bind export node. In the name type filter. It will be a float attribute, so leave everything as it is. If you visualize the filter attribute, then you can see we are getting a few points in red and white color. That's the point we need to keep and delete everything else. Take a wrangle node and write this small code. This is basically going to delete the points who are having filter values less than 0.2. Now take a pack node. Now we are going to create velocity like the image that I have showed on display. To achieve that, take a wrangle node and write this expression. This code simply get the position point of second input and store it as A. Then we are going to subtract the current point position and the second input point position by normalizing it. Take a null node. Take a pop network and dive inside it. In the pop solver, reduce the timescale to 0.5. In the collision behavior, toggle on Add Hit Attribute and in the response menu select Slide. Add a gravity. In the pop source select all points and emission points. The gravity seems too high, let's keep the value to -2. Take a merge node. Add a static object and import our out mesh as collision object. Turn on Use Deforming Geometry. Reduce all the value to 0. Add a pop drag and reduce the air resistance to 0.71. In the pop source node under Birth tab, write Just in Just Born group. Reduce the inherent velocity to 0.32. Add a pop force node and toggle on the group and select Just Group. Increase the amplitude to 200. Decrease the swirl size to 0.4. Add a pop wrangle. Now here we are going to write some Vex code. Here we are going to use XYZ dist and prim UV function. Go to the Input tab. In the second input select SOP path, and in the SOP path select Out Mesh Null. Take a pop spin node. Toggle on axis relative to particle orientation. Increase the spin speed parameter to 1100. In the VEX code write this. Let's import out .geo using .import. Now take a attribute VOP. Take a bind node, we need to import the orient attribute. In the type select 4 float vector 4. Duplicate the bind node, and instead of orient we need to import init orient. This is the one that we created earlier in the wrangle. Duplicate again the bind node. Now we need to import dist attribute. This is the one that we calculated in pop network. In the type select float. Now take a spherical linear interpolation node. Connect our orient and init orient to quaternion 1 and quaternion 2. In the bias connect the dist bind. Before feeding directly into bias we need to adjust the value of dist attribute. To do this take a fit range and adjust the value. Take a bind export node. In the name type orient. And in the type select vector 4. Take a point velocity node. Toggle on match by attribute. Take a line node. Increase the point count to 250. Take a UV texture node. In the texture type select rows and column. In the attribute class select points. Take an attribute VOP node. Here we are going to set the confetti color. Take a vector to float node. Connect it to UV. Take a ramp parameter. Dive outside to set the color. Make sure to set the ramp to constant ramp. Take an add node and toggle on delete geometry but keep the points. Take a wrangle node and write this expression. Take an attribute VOP node. Connect point velocity to first input and wrangle to second input of VOP. Dive inside it. Take a import point attribute node. Connect the output to parameter to file of import point attribute. Duplicate the import point attribute node. Take a near point node and a bind node. In the bind node we need to import CD attribute. For the near point input we need to duplicate the geometry VOP global node and connect it to output 2. Connect the near point output to both the import point attribute. Take a vector to float node and connect it to second import point attribute node. Add a bind export node and in the name write rampview. Add a bind export node and connect it to the first import point attribute node. Take a grid node and let adjust the size so it matches with the confetti size. Take a transform node and rotate it to 90 degree and y-axis. Reduce the uniform scale to 0.8. Add a normal node. Add a UV project node. Now take a copy to point node. Take a unpack node. Before that toggle on pack an instance in copy to point node. Transfer the velocity, dist, color, color 3, ID, rampview attribute. Now take an attribute promote. Change the original class to vertex and select UV attribute. Toggle on change new name. For the new name type UV2, turn off delete the original. If you see and reference the confetti are a little bit bended. Instead of bending before the copy to point, we are going to randomly bend using attribute VOP. Take a bind node. We need to import our UV2 attribute. Change the type to vector. Take again and bind node. This time we need to import ID attribute. In the type select integer. Again take and bind node. This time we need to import the dist attribute. In the type select float. Take a vector to float node and a ramp parameter node. In the ramp type select spline ramp. Take a random node and connect it to ID attribute. Add a fit range and adjust the output value between -1 to 1. Take another fit range and connect it to dist attribute. Change the source max and destination min value. Take a multiply node. Connect ramp output to first input of multiply. For the second input we are going to promote the parameter. For the third and fourth input connect the fit range. Again take a multiply node. Now take a add node. We are going to add the data to the position. Increase the input number multiplier to 0.025. Set the spline ramp as per the bend you want. Make sure to set the interpolation to be spline. As you can see, our bending is happening in wrong direction. This is because we have connected the ramp parameter node to wrong input. Connect it to fval2. Now you can see it's bending perfectly. Add a normal node. For the final step, take a poly extrude node, and extrude it by 0.001. Toggle on output back. If you find this tutorial helpful, please subscribe to my YouTube channel. Make sure to leave a comment, so it will reach to more audience. If you want to support me on Patreon, I will give link in the description. Please like, share, and subscribe.